Hi everyone, welcome to SST College of Arts and Commerce. This is Edupedia. Myself Archana Nair. Here we are going to discuss the topic of difference interpolation method from the course of numerical methods of FYIT semester 2. So what is Newton's forward difference interpolation method? Interpolation method is a method which will be calculating the values with the simple smallest and each and every sessions part by part. This all things will be included and added and processed to will be computed and processed to get a final accurate answer for the given conditions. So here these values will be having two variables, that is x and y. So this will be having n number of representations, or we can also say that it is n number of samples, which is represented by I is equal to 0 to n, where this xi is equal to the interval which will represent the distance of this every x values considered as the interval or the height of the intervals. So that is referred as letter H. So here we can say that xk, we have an equation to find the value of k, that is equal to xk is equal to x0 plus k into h. So here we can say that the k is a constant which will be multiplied with every individual values of the function y. Okay, so to find the respective derivative function y of a particular interval x. So here you can see the equation yk is equal to y0 plus k delta y0 plus k into k minus 1 upon 2 factorial of delta square y0. This delta is represented for the difference between the two previous values of the y. So every time we take new difference values of the two nearest value of the previous session of the y, then we will put it as a delta square, delta cube, delta raised to 4, etc. So that is all levels of the different difference of the values of y, and each and every level will be counted as a power of 1, 2, 3. Here also we have got an equation xk is equal to x0 plus kh, and also we can rearrange this equation to form it into k, that is equal to xk minus x0 upon h. Xk is the value which we have to find, and x0 is the initial value and h is the intervals between the every x values. So this sum will be easily understood by using a solution sum with the samples of table which we have got already. The data is given. By using this data we can solve this sum method of Newton's forward interpolation. That will be helpful to understand more clearly about this method. So here we have got a question: using Newton's forward difference interpolation formula, find f of 12 from the following data. Here you can see a data which is having x starting from 0 to 25, and f of 12 is what we have to find. That means x value is 12. We can see this is having a proper pattern of a difference of 5. 0, 0 to 5, 5 to 10, 10 to 15, 15 to 20 and 20 to 25. So each and every value of x is having a distance of 5. So we can also say the h of this given data is equal to 5. That means that can be calculated by using any after data subtracted by the just previous data of the x values. Will be getting the height or the interval between the values of x. So next row is representing the functions, which is f of x. Also we can represent it using the letter y. That is 7 for the x0, so 11 for the value of x5, 1, and 14 for the value of 10 value of x, 18, 24, 32, etc. Here these values, what we are going to find at the value of 12 for the table x, then what would be the value of f of x. That is what we are going to find. That means if we have got a value in this table as 12, so what would be the value of that 12x in the f of x column? That is what we are going to find using this method, which is Newton's forward interpolation method. So here you can see initially what we have to write, we have to make a columns of x and y, that is 0, 5, 10, 15, 20 and 25. Then the data which is y, that also we have to substitute 7, 11, 14, 18, 24 and 32 according to the given condition of the data from the table. So we have, which was in the horizontal mode, which we have got the data in the question, so that has been converted into the form of a vertical table format. So here you can see that is delta y. Delta y, which represents the difference or the rate of change from the new value to the old value. Okay, so that is what we are going to find. So here we can see delta y is a new column. Delta y, delta square y, delta cube y, delta raised to 4y, delta raised to 5y are the values which we have already computed using the columns x and y. Here we have nothing to do with the column x, but we are going to take it as a reference, so we have to mention this in the table. So I have left different rows, alternate rows in between every values, is because we have to put every difference values in between the values which we have used for the computation. So that's why I have left in alternated lines. You can see that we will be able to understand. So initially we are going to take this value 11 subtracted from the subtracted by the previous value. So 11 is subtracted, so we can say that 11 minus 7, which is equal to 4, and next value is 14 minus 11, which is equal to 3. That I have written in between the value of 14 and 11, I have written that 3. That means it is the difference between the values of 11 and 14. So next is 18. 18 minus 14, we have to do 18 minus 14 is equal to 4. Next is 24 minus 18, which is equal to 6. And next is 32 minus 24, which is equal to 8. Understand? So next, that is the column of delta y. The next one is delta square y. Delta square y is again what we have to do with the 3 minus 4, same pattern we have to do. So 3 minus 4 we are doing, we will get minus 1, and 4 minus 3 we are doing, we will get 1. Then 6 minus 4 is equal to 2, and 8 minus 6 is equal to 2. So that is the column of delta square y we have got. Now we have to find the delta cube. The third level of subtraction is what we are going to do. That is, we can see the delta raised to 3 in the power of that delta. You can see that is the representation of the level of the computation in the subtraction. So here we can see 1 minus minus 1. 1 minus minus 1 will become 1 plus 1. Minus into minus becomes plus. So 1 plus 1 will become 2, that is the value you can see here, that is 2. Next is 2 minus 1, which is equal to 1, and 2 minus 2, which is equal to 0. So now we can go to the fourth level of difference method using the third layer, that is 1 minus 2. 1 minus 2 is equal to minus 1, 0 minus 1 is equal to minus 1. So in the fourth level we got both the values are same. So for the final layer, we are reaching into one individual value. So until we will reach into one value or one value, or whatever it is value it is, but we have to reach it into one value. So that place we are getting 0. Minus 1 plus minus 1 minus minus 1 will be minus 1 plus 1. So that is equal to 0. That means any sign subtracting with the same signs will be getting a opposite operation, which will be a 0. So here we have ready made the function table of the given data using the forward calculation method. So now we have to calculate the h which we have already discussed. X1 is equal to 5. That we have to calculate this, that this value, this will be X0, this is X1, this is X2, this is X3, and this is X4, X5. So we are going to find the value of H by using 5 minus 0 upon interval does not have any calculation division, that is x1 minus x0, that will be equal to 5 minus 0. Also we can take any other value, that is 15 minus 10, also will get a 5 value, because all are having equal intervals between them. So h is equal to 5 we got, x is equal to 6, and x0 is equal to 0. So x is equal to 6 is what we are going to find. By mistakenly I have written the question, you can see this is 12 I have written, so that I have to change this is equal to 6. According to the question we have put the value x is equal to 6, where f of x is equal to 6, that is x. Here instead of 12 we are going to find the value f of 6. So x0 is equal to 0, x is equal to x0 plus hk. So we are going to substitute all these three values into the equation of xk. So we are getting x is equal to 6 is equal to 0 plus 5k, 5k is equal to 6, and we can calculate k is equal to 6 upon 5, which is equal to 1.2. So now we are going to set up the equation for that, since we are having 5 values and we also have got the 5 layers of the difference method of interpolation. So we can say that y is equal to y0 plus k into delta y0 plus k into k minus 1 upon 2 factorial into delta square y0. Because when we are increasing the layer function, you can see how many levels we have increased, that much of factorials we have to divide with. Also that number of k will be taken backward. That means from k we have reached k minus 1, then k minus 2, then k minus 3, then k minus 4. So every 5 factorial or 5th level we will be having 5 forms or 5 values of k, that will be starting from the last value to the backward position, to the reduction values, that is k, k minus 1, k minus 2, k minus 3 and k minus 4. So now we have got all the values of h, x, x0 and k. Now we have to substitute all these values into this equation for y is equal to f of 6 we are going to calculate, that's it. So we have to substitute this all values. So calculation will be easy when we are easily simplifying and finalizing. So here I have done all these values, I have written all these values. So for this method it will be easy when we are substituting all the values together into the equation, then later the subtraction, then later the reduction, then later the addition, subtraction once, then we compute the value, then that will be more comfortable instead of putting all together to get the correct answer. Here you can see the 5th layer, we had a value of 0 as finalized. So we have 0 multiplied with all those 5 vectors, then there is no value multiplied with that, then 5th term is already cancelled. Then here I have put all the values subtraction after the subtraction, and also the factorization has been opened into 2 factorial is equal to 1 into 2, 3 factorial is equal to 1 into 2 into 3, 4 factorial is equal to 1 into 2 into 3 into 4. I have substituted all this together. So I have cancelled some numbers which is the multiples or the factors of the numerator or denominator which is given by. So I have already cancelled them. You can see the which is 0.1, you can see as it is 2 divided by 0.2 divided by 2 we will be getting 0.1, and this 1.2 in the next 4th term which is cancelled by 3, that's why we are getting 0.4, and this 2 cancel with the 2 itself, and in the 5th term we can cancel all the 1.2 has been cancelled by 4, and 0.2 has been cancelled by 2, and minus 1.8 has been cancelled by 3. So the respective values with the decimals we have substituted there. Last term I didn't do anything since it is been multiplied with 0, so entire term is going to be 0, so we need not to put efforts on that calculation. Since it is being multiplied, the result is 0 anyways, so we need not to calculate or think about that while computing them. So while finally after the plus minus multiplication of the negative positives and each and every terms in each terms, so we are getting the y is equal to 7 plus 0.8 minus 1.2 into 0.1 minus 0.4 into 0.2 into 0.8 minus 0.3 into 0.1, 0.8, 0.6 plus 0. 0 is already mentioned to avoid any confusions. Since we are counting how many terms I have already uploaded, so 0 I just mentioned for the knowledge of understanding, to not skip any individual terms by mistakenly. So finalizing this multiplication terms again, once again we will get the final answer of y is equal to 11.6010, that will be f of 6 is approximately equal to 11.6016, because these all methods are the approximation methods which will not be getting you the exact value most probably, but we can reach the nearest value by using this probability methods, by the most probably. Okay, so these are the methods which will be helping us to reach the accurate value at the maximum decimal places. So once we are having the decimal values, at least we have to keep the standard of 4 to maintain the accuracy. Understand? This much is for the day. So we are stopping this session. Thank you so much.